please, I already upload slide, but that one I already macam conteng-conteng sikit. Later I put the original one. Okay, first topic. Just want to brief about set and subset. Okay, this one I think you already learned in previous courses. I think during maths in IT. But this one just to refresh back the idea of set and subset. Okay, before we start, anything? Anything before we start? Ada? Okay, good. I think you know already what is set, what is subset, but today I just we try to go through the idea of this topic. Okay, normally once we talk about set, we talk about the collection. It means the collection of what? Of object. Okay, what kind of object is well defined? So set, we can, in a formal definition, we can say that any well-defined collection of object, the focus about object, but this object we put in one collection, but this collection must be well-defined. What means by well-defined? Well-defined means we know the group clearly about that object. For example, here, the collection of all bird. So we know what is bird, and we can justify which type of bird if we do the collection of bird. And this collection object we call member of set. So this object we utilize word member. The collection means we put as a set. That's why once we talk about well-defined collection of object, we simplify the idea we call member of the set. That's the word I will use, member of the set, not the collection of the object. Okay, for example here, the collection of all birds. It means member of the set of the bird set, sorry. Okay, another idea is real number between 0 and 2. So we know real number between 0 and 2 is 1. So we can justify. Anything that we can justify, in other words, we can well define, so we call member of set. So well defined collection of objects, so actually is member of the set. Okay, in order to represent set, we utilize symbol. In discrete, anything or any sentence or any justification, we represent through symbol. For example, once we talk about set, we represent through symbol like this one. Open bracket and close the bracket. This represent as a set. Whatever inside is a member. Okay, for example, 1, 2. So we have two objects in this set, and that object actually is number 1 and 2. So we represent like this one. So set anything in this world means well-defined collection, we can represent through symbol. Okay, for example here, given by this slide 1, 2, 3. So open and close bracket. Between each object, we split by this formula. Okay. Okay, in set, order is not important. Order is not important. For example, once we have number 1, 2, 3, so we can represent by 1, 3, 2, 3, 2, 1, 3, 1, 2, or 2, 1, 3, and 2, 3, 1. We can utilize any one of these representation in order to represent 1, 2, 3 as a set. Okay, notation in set. Notation means how we justify, means we give the description, and we put the representation of the description. For example, once we talk about notation, it must be have two parts, this part and this part. This part is the description of the object. So how we represent the object? We represent by this symbol. So once we talk about notation, there are two parts. Symbol to represent this description. So for example here, once we put A, B, C, capital letter, so we identify as a set. Once we utilize small letter like A, B, C, X, Y, Z, T, actually we represent the member of the set. That's the standard rule used in set. So this block we call notation. Notation of what? Notation about set. So if you read any maths book or any book, once they said notation or notasi, it means there are two things. First, the description of this symbol. That's the word for notation. Okay. Then once we deal with set, most of the element, usually element in set, for example, set A, we put as X. So in order to represent this word in human understanding, X is an element of set A. So how we transform to discrete? So discrete, for your information, we try to simplify the idea first. We try to simplify the description of human understanding based on sentence word anything, and we transform to the representation. That's discrete. Maths different. Maths we talk about the technique, but discrete we start with notation. We must declare about anything or we assume about anything, then we transform that thing through the representation. So once we transform to a representation like this one, we have this word and we transform to this representation. That's the earlier stage of the discrete step. So X, so set A, so we just put A like this one to represent A. So this word, this symbol means is an element of. So is an element of, we just represent by this symbol. So that's why we simplify this thing, we just represent like X element of set A. That's discrete. Okay, this is the basic idea of discrete. Okay, if we want to represent X is not an element of set A, so we look the X, dx, and A. So X set of A, but here not. Once to put not an element, so we put as element. Not to represent not, we put this symbol, stroke like this one. This way, not this way. This way it means no. That's why if you see some symbol like this one, this is not like this one. This is wrong representation. The correct one is we have this one like this one. It means no entry. Entry means this is an entry. You can, why it's represent entry? Because we can go around. We can move around. Then entry represent by this circle. But no entry, we put like this one. That's why you can look any symbol actually represent the meaning. They have meaning behind that symbol. This entry, so no entry. Here, not an element. Element, not an element. Clear? Class. So actually, discrete we deal with the symbol. Like this symbol. Oh, sorry. Like this symbol, for example, this means happy. This means sad. This is a discrete representation. Okay, get the idea, class? Okay, good. Now we move to the next slide. So, okay, not an element, you put like this one. Okay, one more thing. Before that, stop video, because this video will disturb the network line. Okay, then we move to the example. Okay, given to you this example. So if in any notation like this one, A equal to 1357, it means we have set A, the element in set A is 1357. So we can see that this one is an element in A. 3 is an element in A, but 2 is not an element in A because here 2 do not exist in this set. So we utilize this representation. Okay. Just this listing nothing, this nothing. Okay. If we want to represent a number or character, normally, for example, like represent A, we represent by 1, 3, 5, 7. We just talk about this number, only one single number. How about sentence or statement of P? So how we represent sentence? So in order to represent sentence, we utilize this symbol. So we utilize P, X. So X is the object. P is represent the one group, like sentence or statement. So how we represent in set? We put like X here. We have a set where X as element. This symbol means represent. This symbol represent of one statement or one sentence. So that's why we put like this representation in order to show that collection of all objects for which P is accessible and true. Okay, for example here, X is a positive integer less than 4. So this statement we can represent as X with this symbol. So X represent a positive integer less than 4. So actually, if we put in a set, we can say that A equal to 1, 2, 3. We can represent either through this representation or through this representation. Both are same meaning. So the goodness thing about discrete, we can represent through exactly object, or we describe the object like this word. It means in discrete, we can describe something, and that something we can group as a set. Okay, second example. So second example, set containing of all letters in the word technology can be denoted as. So this word, how we represent this word in set? So we can represent either through this representation. So T, comma E, comma C until comma Y, close the bracket. Or we represent through the description. So X represent, X is a letter. In the word technology. So it's the letter, the word of technology. We take out the main idea, so we put as a description. So we represent through X. That's the idea in set. we can represent exactly letter by letter, or the description or the meaning of that description. Okay, notation. Now we talk about notation, but notation in set. There are few type of notation in set. For example, once we put like Z or Z, it means positive integer. We just put Z or Z, positive integer. Integer, sorry. Z means integer. Once we put like plus here, it means positive integer. If we put Z, negative, it means negative integer. So we can represent through symbol only, without detailed description. Everybody, why? Okay. The question is, why we need to transform to symbol? Why? We can say that positive integer, but some people cannot understand positive integer. For example, maybe from the others country, what means by positive, what means by integer, they don't know. But once we represent through symbol, everybody know about symbol. So once we look Z negative, I as a Malay, I know this is number positive. You as a Chinese, you have your own word, but you can describe in Chinese word, this is positive integer. For Indian, they have the word in Indian word. I don't know. But once you look this one, everybody will understood this one is positive, negative integer. So that's why everything, once we can transform to symbol, everybody in this world can know that thing. For example, like previously I showed to you this one. It means happy. This one means sad. Once you put this symbol to everybody in this world, it means you are sad. So that's the importance of discrete compared to maths. Maths, we deal with technique, we deal with formulation. But discrete, we deal with the representation. How we represent our mind through the symbol. So once you represent, we utilize the same standard of notation, then everybody will understand. Even though just a simple like this image, everybody in this world can understand. Okay? Another set notation, we put n. N actually is number. Once we put n positive, it means positive number. Okay, what is the differences between integer and number? Number, actually we start with 0. Integer, we start with 1. That's the differences between integer and number. Integer represented by Z, number represented by n. Okay, so if we extend this idea, we can represent through Venn diagram. When we have Venn diagram, we can say that if we have a set of n, how we represent Z set. So we just represent like this one, Z. It means Z is one of the type number in set n. But not all number can represent as integer. That's the idea. Another idea, we represent the relationship between number. This Z integer and number. How we represent the relationship? We utilize Venn diagram. So okay. Another thing is Q. Q means rational number. What is the definition of rational number? This definition. You can put like this one in word, or you give a definition like this one. Okay, R represent as real number. Okay, here this represent set but empty set, or we can represent like this one. Okay, empty set and no entry, they have a little bit different. And no entry like this one. From inside, curve this to this. But empty set, so see the line from here to here, outside from this circle. But inside the circle, it means no entry. Here means empty set. We can't represent empty set like this one. This is not empty set. This mean this set have object. The object is this symbol. So in order to represent empty set, either utilize this one, means nothing here, but exit, or here. They have no object like this one. But this one is no entry. This one is empty set. Okay. C has no element. No element doesn't mean do not exist. Totally do not exist. No element, they have no. But the existing of the set, yes. Okay. Can you differentiate? It means this set exists, but no element. Okay. Okay. For example, here, this is empty set. Equal to x. X is a real number, and x squared equal to -1. So this set and this set actually cannot be redundant like this one. So that's why the answer is no set. So cannot be. This is a real number. This one is x and this real number is cannot be overlapped. So that's why empty set. And true or false. Okay, and why? Because of they have no relation between these two sets. Okay, if two sets A and B are not same, equal, when they have a same element. Once they share the same element, totally same, so we call equal. We do not say A and B same. The same is element, not the set. The set equal. So this means equal. This symbol equal. Once we put another symbol here, equivalent. There are two different things. Equal, it means A equal to B. This symbol. If we talk about this symbol, it means A equal to B, and exactly in B, B also equal to A, and they will like each other. Like this one. So we say equivalent. Means we test from A to B, and we test from B to A, and both are, we call are equivalent. Once we say are equivalent, we utilize this symbol. So that's the differences between equal and equivalent. Later, I will explain more detail about equivalent. Okay, example 4. Okay, so if A, straightforward 1, 2, 3, but B, we describe through the description. So it's a positive integer and x squared less than 12. Actually, this operation will be like 1, 2, 3. So actually it's equal. Okay, so far okay? Class okay? Okay, next class we will move to subset. We will talk about subset. So that's the idea behind set. So I hope you can get what is set actually. So next we will move to subset. Subset means contain in. not include in, contain. They talk about element. Later, I will touch it in next class. So for today class, so we stop here. Stop sharing. Okay, that's it for today. I already briefed you about set, and next we will move to subset. So any question? On Ganu, any question? Class? Okay, actually I already upload through online learning, but that one is I already means scratch some words, so I will put again the original one. Okay, how? I will upload the latest one. Okay, thank you. So anything before dismiss? Class? Class? Tak ada apa? Okay, Sam. Thank you, Sam. Okay, Muaz. Okay, tak ada apa. No, nothing. Catherine. Okay, so I think we stop here. So we'll see next week, not Sunday. Next week, Tuesday. Because Sunday, we are holiday here. So see you soon next week, the same day, same time. Okay, thank you everybody. Your attendance, I will key in manually. Total student, 35 student. Okay. Class. Class. Ada apa-apa lagi?
Sir.
Oh, tak ada. Thank you, sir.
Tomorrow?
Tak ada. Okay, siapa nak tanya tu? Kejap. Aduh. Okay. Ada apa nak tanya?
Cikgu,
Ya.
untuk tutor esok ada ke?
Tutor for first 2 week tak ada.
Oh,
They have no tutorial. First 2 week.
okey, baik. Terima kasih cikgu.
Okay. Ada soalan lain? Ada soalan lain?
Cikgu,
Yes, Wong.
kau
Or
ni
Riji.
ada final exam kan?
Yeah, we have a final exam.
Okay. Terima kasih cikgu.
That's it. Allah. Okay, thank you, Riji. Wong Riji. Others question?
Doctor,
Yes.
can you talk about again, why is that the X line X right like that?
Which one?
X
Okay.
line X, why is it right like that? Can you talk about it again?
You mean, oops. Where? This one. Kejap. Wait. I will share it. Okay. Meeting show. Okay. Excuse. Who's asked the question previously?
Yi Cheng Ning Chen.
Chen Ming Ten. Okay. You asked about X, huh?
X line X, that symbol, why is that is right in this form?
Which one? Sorry. I forgot. Ada X. Slide number?
Wait. I'm so not sure which slide.
Wait. X line.
I just
Sorry.
want to know why is right represent in this form. Slide 9.
This one, like this one.
Yeah.
Okay, slide. Wait, okay, this symbol.
Yeah.
Okay, this means X means element. This means represent.
Okay.
So represent of what? Represent the whole thing. Okay, this actually in word it means represent. Represent. Sometimes we utilize this symbol, but we use two symbols like this one. Like for example here. This means once the first we put like this row and this one, it means absolute number or absolute value. For example, if A have -1, 1, 2, -2, for example. So once we utilize this symbol, it will be 1 and 2. Okay, but only one means represent. Okay.
So the first X is the elements and the line is Z.
Yeah.
And
This X actually represent the meaning of this one. So that's why in order to put just X, first we declare, like programming, we declare X is integer, positive integer less than 4. So how we represent here as a variable, we put X. We can put Y. We can put C. So here if we put Y, here we must also put Y. So to show this is the description, the declaration. In programming, we look like programming, this is declaration, this is variable, hold this declaration. So in operation, we utilize this, not utilize this one. This just represent the number 1, 2, 3. So this X. But this is this description represent this value. Okay, Cheng?
okay.
Okay, later, never mind. Later, once we move to chapter 2 and chapter 3, you will see how the uses of this kind of notation. Because in chapter 2, we'll talk about logic. Then you will see, oh, what means by this this description. For example, what means by positive? What means by integer? So how we justify this is true or false later. But in a simple idea, this symbol means represent. Represent this description. Just I said previously, in programming, before you do a programming, you declare a lot of things, a lot of variable that you want to use, the value inside there, you need to declare. That's the idea here. So we utilize set to declare the meaning, declare or description of that idea. This is the idea. So what is the idea? Positive integer less than 4. So once we utilize X, so actually what is represent this idea? Actually 1, 2, 3. So we utilize 1, 2, 3 for here.
So we can also speak as X represent X is a positive integer.
Yep. This one is declaration part. We need in operation we utilize this one. Even though look like similar, but this one is declaration, the whole thing. This one the variable that we use.
Okay, clear. Thank you.
Okay, welcome. Okay, class. Tak ada apa? Nothing? Okay, if No question. Thank you very much.